All right, everyone, buckle up, because today we're going on a deep dive into the world of giant dinosaurs. We're talking about the kind of creatures that would make a T-Rex look like, well, a tiny gecko.
It's fascinating, really, because so often people picture these massive creatures when they think about dinosaurs. But, the reality is dinosaurs came in all sorts of shapes and sizes.
So you're telling me a T-Rex wasn't actually that big? Man, my childhood is crumbling around me.
Haha. Well, no, not necessarily. T-Rex was still a fearsome predator, of course. But it pales in comparison to some of the absolute behemoths we'll be talking about. Imagine sauropods, with those long necks grazing on treetops 4 stories high.
Whoa, okay, you got my attention now. Give me the details. Just how W big did these sauropods get?
Let's start with Patagotitan. This is one of the largest dinosaurs we found pretty complete remains for, at least. Picture this a creature that's roughly 31 meters long and weighs somewhere between 50 and 57 tons.
57 tons. Okay, for our listeners out there, how many elephants are we talking about here?
To put that into perspective, that's about 11 African elephants all rolled into one. And what's even more amazing is the fossils we have are from young adults.
Wait, you mean they weren't even fully grown? Imagine how much bigger they could have gotten. That's crazy.
It really is mind-boggling. Patagotitan falls into the same size category as other massive sauropods, like Argentinosaurus and Portosaurus.
So we've got these supersized sauropods roaming around, munching on trees. Where does Bruhathkayosaurus fit into all this? I've heard it's kind of a mystery.
Ah, yes, Bruhathkayosaurus is a true enigma. The sad truth is, the original fossils that were discovered in India, they don't actually exist anymore.
What do you mean? Did someone, I don't know, misplace them?
Not quite. You see, the fossils were incredibly fragile, and the monsoon seasons in that region of India are pretty harsh. So over time, they basically disintegrated.
Oh, wow. So there's no way to know for sure how big Bruhathkayosaurus really was then.
Well, not exactly. Thankfully, scientists were able to take measurements and make really detailed descriptions before the fossils were lost. And based on those, comparing to other sauropods, they estimate that Bruhathkayosaurus could have been unbelievably massive, perhaps somewhere between 110 and 170 tons.
Hold on, 170 tons. Are you serious? That's like more than double the size of Patagotitan.
It really puts things into perspective. Now, we do have to acknowledge that there's limited data. And things could change as we make more discoveries. But if these estimates are accurate, well then Bruhathkayosaurus could very well be the largest land animal to ever walk the earth.
That's just wild. So earlier you mentioned T-Rex wasn't the biggest predator. Surely nothing could top a 170-ton dinosaur, right?
Ah, but don't forget about the current champion of size, the blue whale. This magnificent creature can reach a whopping 200 tons, dwarfing even the most enormous dinosaurs.
The ocean just has to one-up us, doesn't it? But I guess it makes sense. I mean, water provides so much more support for a massive body than land.
Speaking of these long necks, how did they even work? It seems impossible to get blood pumping all the way up there.
It's a question that has puzzled scientists for ages. Some sauropod necks were, think about it, longer than a bus. It would take a seriously efficient system to get blood flowing all the way up to their heads.
So how did they do it? Did they have, super hearts or something?
Well, there are a few theories out there.
Okay.
But to be honest, the exact mechanism is still shrouded in mystery. One idea is that they might have had multiple hearts, spaced out along their necks, to help boost the blood flow.
Multiple hearts. Talk about a built-in backup system.
Right. Another theory is that they may have had a system of valves and maybe some auxiliary pumps, working along with a really powerful heart to keep that blood flowing efficiently. And then there's the siphon theory. Maybe gravity was actually helping to pull blood down from the head. Wow, that's fascinating. So many possibilities. It seems like they needed some serious biological innovation just to keep their heads up.
Absolutely. It just goes to show how remarkable these creatures truly were and how much we still have to learn about their biology, It's just incredible to think about the scale of these giants. Their size wasn't just for show, though. It actually played a big part in their survival.
Oh, really? I kind of just assumed, being that big, you're basically king of the Jurassic period.
Well, size definitely has its advantages, especially when it comes to defense. I mean, a predator is going to think twice before tangling with something like a Patagotitan, right? But there were other benefits, too. For example, a larger body mass helped them maintain a more stable internal temperature.
That makes sense. It's like how a big pot of water takes longer to cool down than a small cup, right?
Exactly.
Yeah.
And then there's the whole digestive advantage. Their massive digestive systems let them process huge quantities of plant matter, really extracting every bit of nutrition.
So they were basically like giant walking composters.
Haha, in a way, yes. They were incredibly efficient at turning plants into energy, which was, of course, crucial for, maintaining those massive bodies.
So, okay, size helped them stay warm, kept them fueled. But what about other challenges? Imagine trying to just get around with all that weight.
You're right, locomotion was definitely a challenge for these giants, but they evolved some pretty amazing adaptations to help them move efficiently. Sauropods had incredibly strong limbs and this unique system of air sacs connected to their lungs, kind of like birds today.
Oh, right. We talked about those air sacs earlier. They were like,
Mm.
what was it, a super efficient breathing system or something?
Exactly. These air sacs didn't just help them breathe better, they also helped to lighten their overall body weight, made it easier to move those huge limbs.
Talk about a multitasking organ. Okay, so huge lungs and air sacs, strong limbs. What about their bones? I mean, they must have had to be super sturdy to support all that weight.
Their bones were incredibly strong, yes, but they also had kind of a neat trick. Many sauropods had these hollow spaces inside their vertebrae, helped reduce weight without compromising strength.
So, like, built-in weight reduction. Nature is amazing. But I'm still curious about how these giants even, came to be in the first place. What kind of evolutionary pressure would lead to such extreme sizes?
Well, picture a world with lush vegetation everywhere and a warm climate. That's what it was like during a lot of the Mesozoic era, the age of dinosaurs. Basically a paradise for herbivores. And with so much food around, there was strong evolutionary pressure to, well, get bigger, outcompete your rivals for resources.
So the bigger you are, the more you can eat, the better your chances of survival.
Exactly. And, of course, as the herbivores got bigger, so did the predators that hunted them. It was an evolutionary arms race, you could say. Size became a key advantage on both sides.
Right, that makes sense. But eventually, the dinosaurs, giants and all, they went extinct.
Yeah.
What happened? Was it like a sudden catastrophe or more of a slow decline?
The most widely accepted theory is that a massive asteroid impact about 66 million years ago was the main cause of the dinosaur extinction.
The infamous asteroid. So it wasn't a gradual thing, just boom, lights out for the dinosaurs.
Well, it wasn't quite that straightforward. The impact itself was definitely catastrophic, triggering huge earthquakes, tsunamis, wildfires. But the real killer was probably the global environmental changes that came after.
Like what kind of changes?
Well, imagine a massive dust cloud covering the whole Earth, blocking out the sun for months, maybe even years. This would cause a drastic temperature drop, disrupted plant life, and basically caused food chains to collapse.
So the asteroid was kind of like the first domino,
Yeah.
setting off this chain reaction that wiped out the dinosaurs.
Yeah, exactly. It's a bit of a sobering reminder, of how fragile life can be, even for creatures as powerful as the dinosaurs.
It really does make you think. Okay, so we've talked about giant dinosaurs on land, but what about in the water? Did gigantism evolve in the oceans too?
Absolutely. The oceans during the Mesozoic era, they were home to some truly impressive marine reptiles. In fact, some of them rivaled, maybe even surpassed, the sauropods in terms of size.
Okay, now you've got me really curious. Tell me more about these underwater behemoths. Okay, so we covered the giants on land, and you've mentioned these massive creatures in the water. Tell me more about these underwater behemoths.
Imagine a world where reptiles rule not just the land, but also the sea. We're talking ichthyosaurs, plesiosaurs, mosasaurs. These weren't your average lizards.
Those names are a mouthful. Break it down for me. What were these marine reptiles like?
Well, ichthyosaurs were sleek predators, like dolphins almost,
Oh,
Powerful tails, sharp teeth, perfectly adapted for chasing down fish and squid.
like the cheetahs of the ancient seas.
Exactly. And then there's the plesiosaurs, the long necks, broad bodies, and these powerful flippers.
The long necks, were they related to the sauropods, the ones we talked about earlier?
Well, their necks might look similar, but plesiosaurs and sauropods actually evolved those features totally independently. It's a great example of convergent evolution, where different organisms develop similar traits, because they're adapting to similar environments or lifestyles.
So two different branches of the reptile family tree figuring out long necks were the way to go.
Well,
Cool. What about those mosasaurs? Where do they fit in?
mosasaurs were more closely related to modern-day monitor lizards and snakes, actually. They had streamlined bodies, powerful tails, and these scary jaws just lined with sharp teeth. You could say they were the ultimate ambush predators, lurking in the depths, ready to strike.
Okay, you've definitely painted a picture with these ichthyosaurs, plesiosaurs, and mosasaurs.
Yeah.
But were any of them truly gigantic? Like, those sauropods on land?
Absolutely. Some of these marine reptiles were huge, even dwarfing the largest land predators. Take Shastasaurus, for instance, a type of ichthyosaur.
Shastasaurus. Tell me about this one.
Picture this, a creature over 20 meters long, a streamlined body built for speed and endurance. Shastasaurus is considered one of the biggest marine reptiles ever discovered.
20 meters. That's longer than a bowling lane. What did something that big eat?
Well, it's interesting. Despite its size, Shastasaurus probably ate relatively small prey, things like cephalopods. It seems its toothless jaws were adapted for, like, sucking in schools of squid or other soft-bodied creatures.
So a gentle giant of the deep, like a whale shark, filtering out tiny organisms.
Great analogy. And speaking of filter-feeding giants, we can't forget about the largest animal to ever live, the blue whale.
Got to give the blue whale its respect. It's the undisputed champion of size, even compared to those ancient marine reptiles, right?
Absolutely. The blue whale really is in a league of its own, up to 30 meters long and some weighing over 170 tons. It's really a testament to the incredible diversity and scale of life our planet has seen.
Wow, this whole journey through giant creatures has been incredible. Behemoths on land, in the sea, even the skies. It's amazing to think about how gigantism evolved in so many different ways.
Yeah, it really highlights the power of evolution, shaping life in these extraordinary ways, pushing the boundaries of size and adaptation.
I think our listeners are leaving with a whole new appreciation for the giants that once roamed our planet, and maybe even a bit of awe at the incredible power of nature.
I hope so. And remember, there are still so many mysteries out there, countless secrets hidden in the fossil record. Who knows what other giants are waiting to be discovered, right?
It really is a thrilling thought. Thanks for joining us on this deep dive into the world of giant creatures.
My pleasure. Keep exploring, keep questioning, and never stop being amazed by the wonders of our natural world.